Welcome back, everyone, to ABG Investor Days. My name is Henrik Hintze, and I'm an equity research analyst here at ABG. With me now, I have the CEO of I-Tech, Philip Chaban. Philip, please take it away.
Thank you, and nice to be here. Despite the snowstorm, we managed to get ourselves into this conference room with great energy. And we look forward to walk you through this presentation, which is a bit odd. It's about biochemistry applied in marine coatings and used then in the global shipping community. So that's what we're here to talk about. I-Tech is interface technologies. It is not an IT company. It's actually a biotech company. We are coming through a year with a tremendous success. We have a great growth, we have good earnings, and we are supported by global mega trends in efficiency of shipping, and also on regulation starting locally in parts of Asia around the coatings themselves. And the 1% limit here is a biocidal limitation that we'll come back to briefly later. But a very strong year that we will talk a little bit more about. But first, the company. The company is listed, Nasdaq First North. It relies on strong IPR, so it controls both downstream and upstream IPR. Most importantly, it controls regulatory approvals, which is a lot more effective in this business. And that's what we have in general, except a large team and all that, of course, a large team, a good team, I should say. We are driven by making shipping more efficient. Although we're an ingredient technology in the paint bucket, the purpose is to resist biofouling on the hull. And biofouling creates drag, and that's something we don't want to have. So avoiding that makes shipping efficient. And sustainability comes along with that, because saving fuel saves emissions to air. In addition, this strong little molecule also replaces or is capable of replacing other ingredients in the coatings that can optimize the chemical loadings within those paints. And as I mentioned, it's an ingredient technology. We call it Selektope. I'll inform soon about how that name is composed. And it has a huge scalability as a company. It's been a very long story. I won't go through all this, but typically startups are not this long, but we are very happy that we survived all those first 15 years before things started to take off. There are some synergies here, or some very alike things with the pharmaceutical development plans. It takes for ages. It takes about 10 years even to get a first regulatory approval on the authority side. Then it takes 5 to 10 years on your side to get in all the papers. So that explains why this takes time. We won't get deep into that, but we will explain what drives us to go to work every day, even a snowy day like this. First of all, the shipping community is responsible for around 2.6% of global CO2 emissions. That's the number of the entire emissions footprint from Germany. So it's a huge contribution. And the reason for that is that we're a global infrastructure, right? Things are produced in one country and shipped to the other. So a lot of goods, probably 80% of everything we buy has been on a ship. To reduce this footprint without harming the globalization is essential. The other part is the marine ecosystems. Going into the waters, you find a certain marine ecosystem, and in another area you'll find another one. But if you start to transfer things between, they will get mixed up, and that's a danger. You can have the risk of invasive species that are then blocking off and destroying the local community of species where you are, and that is undesired. And there's regulations around that, as well as we're seeing parts of the world, at least one of the big shipping countries, starting to put their finger on the necessity of overloading chemicals in a coating to achieve a certain effect. And in this context, we as a biotech ingredient company can help reduce those loadings. So less chemicals should be leached out to the environment without compromising the other two aspects. This is what drives us to go to work. So what are we then doing? Well, we have a very specific molecule that attaches to is consumed by the barnacle larvae when they approach the surface, provided that the molecule is available on the surface. That then triggers receptor stimulation, a natural receptor stimulation. In this case, the barnacle goes hyperactive and is forced to move away. It cannot settle. So it relies then on biotechnology. The other part is that it's the shape of the molecule is such that it really sticks very well into the paint. And that is the two secrets why this works so well. The effect of this is that it's super specific. It doesn't affect any other animals. It doesn't cause any harm to anything else at the recommended concentrations. And it is then repellent, so it doesn't cause any risk of resistance buildup, which is one of the upcoming issues on other technologies potentially. So moving these creatures away from your surface to your competitor surface is a good thing. And to avoid the buildup of barnacle shells, which is the things that create a big drag, that creates a huge fuel saving potential. I'm not saying that every ship looks like this, but I'm saying that in a worst case, it can look like this. And it's about ensuring yourself that you don't have a ship that looks like that. Because if you do, you're looking at 40 to 80% extra drag to move that ship the same distance forward. It's a tremendous risk that you're subject to if you don't take the right decisions on coating technology. And that is why Selektope is now introduced to the paint. Selektope, selective, it affects the octopamine receptor, Selektope. So what is then a paint consisting of? So it's a coating layer and it's a water, right? And the secret here in the normal traditional coating systems is to move binder system, which is the thing that puts the paint together, with the biocides and move them gradually out to the surface, and then they are leached out. We are part of the biocide pack, so we are part of those yellow dots in here, right? So it's about moving these steadily, consistently through the paint over a 5-year system. And that should be designed in a way that it adapts to the speed of the ship, the salinity of the water, and the temperature of the water. So it's quite advanced. Most coatings that are sold on the shipping market contains biocide. I would say more than 90% would contain biocides. 85 to 90% are self-polishing, meaning that this red layer is down to 0 at the end of the 5-year cycle. So what is leached out is quite important. All these, and there's another system called silicones, which are not leaching, reducing their thickness, but that have other modes of action. Slipperiness that takes away the fouling. Even those systems contain biocides. Okay, so all the functioning marine coatings are containing biocides, right? So what is then a biocide? Biocide is something that's a biological effect, something that affects biology, but it's not physical, right? So a light system would not qualify as a biocide, but any chemical compound that has an effect, even if it's not lethal, it still is a biocide. Okay, so we're on the borderline here. We don't kill, we create the flight mode, but we're still classified as a biocide. We're only 8 such agents in the whole world, molecules. 8 such molecules available to the paint makers that are then producing all of these paints. And that is a very low number to start with, because the biological spectra is quite large. And we are the only one that has this repellent mode of actions. We're even the only one that has any effect below 1%. In fact, we have an effect at 0.1%, right? Which makes it possible to combine with any other ingredient in those coatings, which is not true for the other 7 compounds. So that's one good important thing. Normally, a coating contains 2 or 3 days biocides, so Selektope needs to be formulated alongside something else. So it's not solving the full problem, and that's important to know. So it's a combination of a few biocides, the binder system, that creates the effect. Now, this was a coating lecture, because I thought it was time to do so here, first time at ABG. The business model to produce this biocide and sell it and make money of it is as follows. Super complex factory that we don't own. We have only a supply agreement. We own the IPR. We own everything, how to do, so to say, the tech pack, but we let someone else do it. This is then shipped in a smart container. Now, remember I talked about the 0.1%. That's tremendously small amounts, right? That's a few grams per liter of paint, which means we can be very innovative in how we supply this material. We supply to the big paint makers in a closed canister that's like a dishwater tablet. So you just take it out of the rigid container, you put it in the production system, and it dissolves, so you're not exposed to the powder. Okay. So sophisticated factory with an intelligent way of shipping and delivering the powder to markets where we have regulatory approvals and everything in between, by the way, because they're non-regulated, the gray ones. And then we ship and sell to the big paint makers in the world. 3 of the 9 largest are displayed here. Out of those 9, 6 control 80 to 85% of the global market. We don't have a massive number of customer calls to make. We have about 9 big customers to care about. A few more on the leisure boat side, but that's about it. Now we're coming into the scalability of the case, right? We don't even see the material. We're 10 to 15 people in the case, right now 10, plus a few consultants. But with 15 people in total or something like that, we can serve all of these clients and 5-fold today's revenues. Everything is already set up. The production plant, the customers, the distribution systems, the approvals. And the good thing is that all those 9 customers are on it. So if everyone is developing around this technology, not saying it's going to be the only solution to all the problems, not saying they will only go with Selektope. No, that won't happen. But some of them are really into it, like the top one, which is Shogoku Marine Paints. We can disclose, that's not a secret. They're ongoing with research, they like the idea, they try to twist. They have new building products on the market, so new building is for new build ships. They have dry docking products on the market, which is a volume market. 10,000 ships per year are getting new paint. And then we just follow on and see that we have a good relation to all the 9. 3 of those are on both those different product markets. 6 of them are new buildings. 2, we believe, have a fair chance, given their current stage in the R&D, in the product development portfolio, to actually come up with new products within the next 12 months. That's our own estimation. So very good customer position. Long relationships, 10 years with each of these. They know me before I was gray in my hair. So the ships that we are mostly focusing on together with the customers is these guys. They have a tremendous fuel bill. A small, medium size of these ones is 25 tons per day. A large one is 200 tons fuel, diesel per day. That's a massive amount of fuel. They gain a lot of having clean hulls. It's worth money, a lot of money. So that's where we all start. And the good thing is that every year, 10 to 15,000 of these need to come into dry dock. It's not a choice. They have to. It's a 5-year cycle. And knowing that's about 55,000 of these vessels, not all that big, but then divide that by 5, sometimes 4, depending on the strategy, you have a lot of ships to target every year. On top, you have 1,500 new builds per year, which is a small number compared to dry dock. So it's all about getting into dry dock market. Then we have work boats and leisure boats. Different case, less of interest for this more expensive coatings at the moment. But that gives you a glance of where we are. I talked about mega trends. One is the design of a ship, put in place January 1st, 2023. How good is your ship on a scale? As of your design decisions, the bulb, the shape of the ship, the engine choice, the propeller choice, right? Things you don't change. That's in works as we speak. From January 1st, you also start to measure how good you are year on year in improving your efficiency. Nothing to do with the choice of engine, nothing to do with the shape of the ship, but a lot to do on how efficiently you operate the ship. Could be the captain's behavior, could be advanced propulsion optimization systems, and it can be the coatings. Generally, 20% of this will be impacted by the coating itself. So this is a huge driver for continuously improving efficiency and investing in good technology like coatings. We talked about marine ecosystems. Just recently, a few of these big cruise ships were trying to, on their scheduled route, approach Australian harbors. They were denied. They were denied because they were fouled. And fouling means risk of bringing in alien species. Could be invasive species. So authorities said, you're not allowed in here. Go away. Go somewhere else. And somewhere else means out in the non-territorial waters with a diver that cleans it. And that cleaning process destroys your coating, which means you're up in dry dock half a year from now probably. And that was not a good financial experience because obviously you had to take all that time and cost of the diver, but the more problematic thing was probably all the passengers you brought around that couldn't reach their destinations, right? I think they skipped half of its scheduled port calls. and that's away from the specification of the trip they were claiming. So this is another important area, very much related to the coating and the maintenance of the coatings. All right, we skipped the quarter, look to the year. A strong year development. We've been in the business long, so for us this is a dream coming true. For you it's probably expectations. But we've been in here quite some time before we even knew what a dollar was. And now it's taking off. And it's taking off after some years of quite moderate growth, which investors were quite upfront with. And now we're back in a situation where it is growing, to not only growing, but profitable growth as well. As you can see, there is currency effects in this, I should say, right? But the growth in the year was 33% if you take away the currency effects, 58 in total. And EBITDA margins are getting more and more solid. Looking at the scalability of the case I talked about, here's the evidence that it may actually be true what I'm saying here, right? We may actually be able to deliver this. And for the first time, a really strong positive net result. Opportunities driven by megatrends, the growing customer base, and enhanced activity in all these R&D departments, driven then mainly by the top aspect here, that they need to improve and reduce their biocidal or chemical loadings in general. But there are also risks. There's regulations on chemicals. That is always an issue in the debate. PFAS things, not related to this, but as an example, things will happen in the chemical industry, and this is a challenge for all of us. And cost performance is always a balance, because a ship is 5 years in operation. It takes time to prove a higher price for a coating. It's not just replacing. And the raw material situation in general has been managed extremely well so far, but we cannot guarantee that at some point that might cause a challenge. Our last slide is about our outlook, and knowing that we're now happy to be growing quite a lot with one customer, should be said, we're not in a position to start to put real numbers out here saying that we will have a 30-50% growth per year or anything like that. It's still some things that need to be in place before we see a more consistent baseline to make such judgments. So instead we say that we will grow. It is looking really promising on the growth side, and guess what? It will be profitable as well. And that is basically what we will say. The important thing to keep control of is our general reporting like this, and the customer development, which we hope will then be with all those 9 customers rather than one, which is the main driver at the moment. By that, I say thank you and look forward to questions.
Thank you for that. Let's move on to some questions.
Yep.
First of all, I just have to ask, how did you come up with this idea, this solution, and applying it to this problem?
First of all, this is a long story, right? So I have not been part of the first phase. It originates actually out of a Swedish interest and initiative to save our own waters. As back in the days, there were very troublesome chemicals used in the coatings. Extremely efficient, but with a very bad footprint in the environment. So the idea was to try to come up with something that at least could protect our own pleasure boats in Sweden, right? And they put together a very interesting team of scientists, both on the chemical side, but also on the biology side and on the pharmaceutical development side, so to say, right? And then they started to figure out which of all these species to care about. Well, it's the barnacles. They are the public enemy #1 in the industry. That's why you use the TBT. That's why you use the 50% loadings of copper oxide and all that, which was the target at the time. And thanks to the group of the setup of the group, they started to look into DNA. How can you actually trigger these to not come here at all? Because when they come, they glue very hard. And that is the problem, right? Once that happens, you're done. So how to make them not want to come here at all? Well, then they come up with analyze the receptor stimulate the DNA, and it identified the receptors. This is pharmaceutical development, as you know. You try to screen molecules that fits into a certain receptor, and then you hope and hold your hat that actually creates an interesting behavior. It should have fallen asleep, because that's what happens if we consume this molecule, which you should not do, by the way, if it happens. These guys got hyperactive, and that was pure luck on this specific molecule. There were other molecules identified that should have triggered that, but this one did. So that's a large amount of patience, luck, and obviously know-how from university researchers. That's how it started.
Very interesting. Could you tell us a bit more about the competition in this space? Who are your competitors, and how good is your IP protection with regards to
Right.
this?
So the competition is mainly on the selection of components to give a certain effect, right? So I had one slide here trying to be a little more detailed than normal about how paint works. So there are 8 different biocides. We know that all paints today, silicones or self-polishing, that have a proven strong performance over a 5-year period contain biocides. Okay. Then it's a matter of selecting them at the moment. And there's 8. Only 3 of those have a pronounced effect on barnacles. Right. So you can either upload your coating with a lot of copper oxide, which is a traditional way to do it. You get a certain performance, right? Or you can go for Econia, which is another non-metallic biocide. Also gives you a good barnacle protection. Or you could do only Selektope, and you can do Selektope in combination with any of those others, which is a good selling point for us, because all these agents are needed. The question is, how can we combine this in the most optimal way? So in one way we have competition, right, in terms of high loadings of copper or Econia, right? But we don't see it like that. We see that we need each other. We can either boost their performance if they wish to formulate with any of those two, or we can help reduce those levels for the sake of a sustainable storyline. Then there is non-biocidal coatings, and that's a competition as well, but that's mainly for Swedish leisure boats.
All right, all right. So you said that the last year was pretty much where sales started growing significantly. Why do you think that was? What happened?
Well, it was driven mainly out of Asian-based customers to start with. The main customer, the strongest contributor to the top line, again proved that there's a new level in their product portfolio with our technology. So during COVID, they expanded the product portfolio by double, right, 100%. And those products are now getting into the waters and getting into the sales process, and that generates a new revenue line, right? Because more products generate more sales for us. So they have taken a stronger approach to us. But it's not only that; it's the fact that we have 6 of the 9 biggest as customers. Most of them are new building, yes, but our footprint in new building is getting quite big, and that's the nature of this technology, that it can sustain very long times in idling. Idling means don't move. You don't move, right? And that's where you have the fouling challenge. And with the power of our molecule, you can extend that idling quite a bit, either by combination of what we just talked about in terms of the biocides or alone. And that's what drives it.
Thank you very much for that. That's all we have time for. Thank you all for listening.
Thank you.